Let me now get rid of this. So here we have declared a struct. We have passed a variable to it and also a pointer to it. So so I have passed this too. Now I want to copy this statement. Control C. And let me paste it here. So we can use the name. Let me delete completely this and also delete this one. So we can completely use the type now because the pointer helps us identify our type coordinates of struct. So we can just use struct ptr. Then in this case, we use the arrow. I can say of x that way, and I can also say the struct ptr of y this way. If I compile these two, I'm going to get a segmentation fault. Why? Who will tell me why? Why are we getting a segmentation fault?
Because haujaassign any address.
Yeah, this is just a pointer. It is something that is hanging on the memory address. It does not have a reference. Where is it? Okay, there is something you will come maybe to meet in the future called LHS and RHS. ALX will never teach you this. So RHS is called right hand side, left hand side is this is left hand side. So let us come to this statement. 3.5 is called RHS lookup. It is on the right hand side of the coord.x. LHS is on the left side. So every time the compiler is trying to access something, it does these two things. It does a left hand side lookup and a right hand side lookup. So the engine itself is trying to have a conversation with the compiler. In this case, here, if I come to this, so here the engine is where engine first comes, it here in the main, for instance, it tries to check, it finds something called codes, then codes. So engine will the engine will ask the compiler, hey compiler, I am trying to do RHS lookup of coords. Could you know where it is? Then the engine will, the compiler will say, yes, there is an LHS uh, reference for coords somewhere. It was declared in a global scope. So it will tell him, it will tell the compiler will tell the engine, yes, it is true that struct coordinates exist and it has a right hand side. It has a left hand side reference for coords because this is the name associated to that struct. Then it will continue. It will come here and do coords.x. So this is a LHS lookup. So what LHS lookup does, its work is to check if there is any value that is associated to it. So it will continue, then it will come to the printf statement, and while it is trying to do this, it will find printf. So the engine will ask the compiler if it knows what printf is. Then it will be told a printf is a keyword. It is an inbuilt keyword. So don't worry about it. Just continue. It will come to x coordinates.x. So when it reaches here, it does a left-hand side lookup and asks the compiler, hey compiler, could you be aware of cohorts? Of course, I know I asked you this later, but are you aware of cohorts? Then the compiler will tell him, yeah, it is still the same thing I told you before. Then dot, oh, no, it realizes I am trying to reference something of cohorts. So it will ask him. So I'm going to do an LHS reference lookup for X. Are you aware of him? Then it will tell the compiler will tell engine, yes, X is 3.5. It will also continue here and tell him the same thing. But when we come to this, when we reach at this point, so here the engine will ask the compiler, hey, I have met a pointer here called struct pointer. Are you aware of him? Then the compiler will say, yes, I am aware that struct pointer exists. He was declared somewhere. Then that somewhere is here, of course. Then he will continue. Remember this arrow means give me the x of struct pointer. Then it will try and say and see, hey, I'm trying to do a lookup of struct pointer x. Are you aware of him? Then he will tell him no. Struct is just declared, but it doesn't have any member associated to it. So to make things clear, now let us come here and say something like this. Struct pointer x equals maybe 1.5 that way, and then struct pointer of y equals 3.5 that way. Okay, let us have it unique. Maybe it can be 3.0. And then let us recompile this and rerun it. We are now totally getting a segmentation fault. So what is happening? You must associate this struct pointer to this struct. And the only way you do so is by linking this to the memory. So we can say equals the memory is cohort. Now let us recompile this and let us run it. Perfect. It works. Now, when the engine is doing right-hand side lookup for struct pointer.x, he will be told, yeah, this guy exists. And he is pointing to coordinates.x. And also struct pointer.y is also pointing to coordinates.y. So in other terms, the compiler will be telling the engine, hey, struct pointer.x and struct pointer.y is the same as coordinates.x and coordinates.y. But when you leave it this way, it is just something hanging on the memory. It doesn't have any member. It doesn't know who it is. It is just there. You can't reference it. So that is why it is trying to give you segmentation fault, core dumped, because you are trying to access something of that name which is not even associated to him. So it doesn't know where to look for it. So this is a pointer. What if I did this? Let me copy this. Control V. And instead of using the arrow, I use dot. Dot. I also use dot here. I do dot. But again, I first dereference this. I also dereference this. Will this work?
Yes, it will work.
All right. No? It is not working.
The static should be inside the bracket.
What is wrong when it is outside the bracket? What does this statement translate to? Here, I am trying to have struct dot x, then first I'm trying to do struct dot x, then I dereference later. I don't know if you are taught the spiral lookup for pointers. You start from struct clockwise. So we start from struct clockwise is this way. We first struct, then we go clockwise. We will come to x, then we still go clockwise. Later on, we will arrive to x. So what does this mean? Since we are doing a clockwise lookup, so we'll start this way, struct. So what is a struct? Struct is just a pointer. Then we go to x. X is a float. So you are trying to associate uh, struct to a float, which are totally two different types. Therefore, it will raise an error. But if we remove this pointer there and then we put it inside here, now we go to body mass. Start with the bracket first, then whatever is outside the bracket later. So when we do this, it compiles. Then we get our answers. So there are two ways. You can either dereference the structure pointer so that you access whatever is inside the address. Or you can just use the arrow this way. So that is a pointer. That is now just a pointer to a structure. So we declared our pointer here, then we passed the address of our variable. So here, this structure is pointing to the variables, meaning, meaning if I want to alter x, I can use structure. I can just say struct pointer dot x is no longer 3.5 but 4.5. So if I run this, we are going to get 4.5 for x. So that is now the power of pointers. You can just do direct, you can directly access a member. I know you are told about these pointers. Last time I remember we talked about memory, we talked about the heap, and we talked about the stack. Talked about uh, reference data type and static data types. So that is the difference. So when you are doing a memory pointer, this and this is still the same thing. This is just a metaphor. Struct pointer is a metaphor to coordinates. So when you say struct pointer, you simply mean coordinates. Well, so that is a pointer. Any question up to this point?
Hello.
Yes.
Unaweza kurepeat hiyo point ya kama umeweka the asterisk outside of struct pointer.
So hapa tulisema tukiweka hapa nje, if we do this, what we are trying to do is Yeah, first, when the engine comes to this, it knows the whole of this. It assumes the whole of this is a pointer. Other terms, it dereferences the whole of this statement. But we know struct pointer is the only pointer here. X is a float. You cannot dereference a float, and therefore that is why it is raising an error. You are trying to dereference a structure, then you are trying to dereference a float. In other terms, you are dereferencing structure pointer of X. That does not happen. Uh, the reason as to why this is happening, I have told you, is in pointer, there is something we call clockwise lookup, spiral, the clockwise spiral. You start with the name itself, which is a struct pointer. Then you start doing a clockwise spiral. The clockwise spiral here is struct pointer, clockwise spiral next is X. So struct pointer, we know very well that struct PTR is a pointer to a struct to a coordinate struct type. Then we go to X. Then we continue going spiral. Then next we reach is the asterisk. And we know asterisk is used to dereference. So you are saying the reference struct pointer of X, that does not happen. You must dereference the pointer to access the member X. But you cannot dereference struct ptr.x as a whole because X is a float and struct pointer is a pointer. So it will complain. The compiler will tell the engine to return an error.
Okay. Elewa.
So always use board mass, I don't know, bid mass. Some call it bid mass, some call it board mass.
So like gani iko na more precedence cause nilikuwa nimesoma mahali ilikuwa inasema like if you're like the vile unaweza like the same nini understanding ya if you're doing arithmetics unatumia hiyo board mass, so like precedence in a the parentheses have a higher precedence than any other operator. So sijui
Exactly.
if so in our case like kama the asterisk iko nje, wouldn't the precedence be on the struct pointer first alafu iende kwa the asterisk before ikuje kwa the dot?
Hapana.
Oh,
Inajaribu, well, remember the asterisk is outside. So tukitoka kwa struct pointer, our next point is X, but the asterisk is outside. So inaanzaga na jina kwanza, the name is struct pointer, then what follows it next is X. Then after it is done with that reference, struct ptr.x, now it tries to dereference the whole of it.
oh,
And it is going to raise an error. Instead,
okay.
ukiweka hapa ndani, itaanza struct pointer dot. So itaanza na dereference, it will first dereference struct pointer.